So a very good afternoon everyone. Just confirm audio video is clear. Kindly confirm audio video. Kindly confirm the audio video. Is it clear to you? Kindly confirm audio video is clear. Kindly confirm the audio video. Is it clear to you? So a very good afternoon everyone. Myself Prateek Mishra and I welcome you all to the YouTube platform of IMS Gate Academy. Foundation course is ongoing and I hope you have enjoyed the previous sessions. All those sessions are there to make up your basics to read the environmental engineering with full conceptual clarity. I hope you have seen all the previous sessions that I have conducted, whether it is a session starting from the water demand, then we conducted sessions for different other topics. Today we will going to deal with one of the very important areas of environmental engineering, that is disinfection. My dear students, we are regularly seeing questions asked from disinfection. Reason being, disinfection is one of the most important treatment given to raw water. Imagine yourself consuming a water which is full of pathogens, disease causing microorganisms. That will going to cause you so many diseases on regular intervals. So any water which is supplied to the community first needs to undergo the process of disinfection, and today we will going to discuss all the basics which are required to treat or disinfect the water. But before we start this, I would like to make few announcements. First announcement is regarding our Telegram group. If you want to have the lecture PDFs, YouTube session details, you want to have daily job notification updates, so you can join our Telegram group. The link is given in the description box. Next, if you want to enjoy the daily quizzes, again we provide them in the Telegram group, so you can join that. Link is given in the description box. We at IMS Gate Academy, my dear students, offer you 800 hours of live teaching with interaction, where we provide you with 4 different types of courses: online program, offline program, hybrid program, and the self-learning program. In that, we provide you with theory and exercise book, and our exercise book contains more than 4,000 practice questions well versed in level 1, level 2, and level 3. Along with that, we provide you with a comprehensive GATE question bank containing GATE questions from last 34 years, which includes the detailed solution, alternate solution, key points, chapter overview, and the video solution of the challenging question. We provide you with 12 personalized one-to-one mentoring sessions so that your studies are oriented and well planned throughout the journey of GATE preparation. And we provide you with India's largest test series containing 130 plus tests, which starts from the chapter test, subject test, multiple subject test, advanced subject test, and the full length mock test with the video solution. So if you look into the overall package provided by IMS Gate Academy, it includes more than 8,000 questions provided to you, along with 800 hours of live teaching with interaction. Along with that, our faculties are regularly available for doubt solving. No other platform is doing so, and we are delivering it very efficiently for over past years. With these words, I would like to start my discussion on disinfection. So my dear students, there are 2 terms. First one is disinfection and second one is sterilization. Can you tell me what is the difference between disinfection and sterilization? What is the difference between disinfection and sterilization? What is the difference between these 2 words? First one is disinfection and second one is the sterilization. I hope you might have seen these 2 words somewhere or the other. First of all, if I have to explain you this, you understand it like this. If I talk about microorganisms, microorganisms are of 2 types. Disease-causing microorganisms, disease-causing microorganisms, disease-causing microorganisms, and harmless microorganisms. Harmless microorganisms which does not cause any disease. Disease-causing microorganisms are known as pathogens. disease-causing microorganisms are known as pathogens. These pathogens are responsible for causing the disease. So if you are killing only the disease-causing microorganisms, that is known as disinfection. Killing of only disease-causing microorganism is known as disinfection. But killing of all the microorganisms present in the system is termed as sterilization. Sterilization is killing of all the microorganisms, killing of all the microorganisms, killing of all the microorganisms present in the system. Disinfection we do for treatment of water. Sterilization usually doctors do if they are performing any surgery. If you regularly visit any dentist, you will find out that all the equipments which are used by the dentist are regularly sterilized. Okay. So sterilization means killing of all the types of microorganisms present in the system, whether it is a disease-causing microorganism or the harmless microorganism. But specifically talking about killing of pathogens, it is termed as disinfection. Now, my dear students, this disinfection is carried out using two methods. Next is methods for carrying out disinfection. So, disinfection is carried out using two methods. Disinfection is carried out using two methods. First one is known as the physical method. And second one is known as the chemical method. There are basically two methods for carrying out the disinfection, physical method and the chemical method. Again, in the physical method, it includes boiling the water. Physical method of disinfection is boiling the water. The second physical method of disinfection is UV ray treatment. The second method of disinfection physically is UV ray treatment. Now, in both of these physical methods, we are not chemically treating the water, as simple as that. We are simply killing the microorganisms physically, either by boiling them or by making them in contact with the UV rays. Okay. Then we have the chemical method of disinfection. In chemical method of disinfection, the first method is treatment by acids and alkalis. 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 The first chemical method of disinfection is treatment by acids and alkalis. The second chemical method of disinfection is treatment by metallic ions. Treatment by metallic ions. Like copper, silver, gold, we have treatment by metallic ions. Metallic ions like copper, silver and gold. Okay, usually we see all these utensils that are used earlier are either made up of copper or they are made up of silver, right? The basic reason for these use of utensils is these metallic ions are good disinfectant. They kill the microorganism if any present in the water supply. Then you have the third and the most prominent used method of disinfection, that is treatment by oxidizing agent. Treatment by oxidizing agent. Treatment by oxidizing agents. These oxidizing agents include chlorine, then you have ozone, then you have peroxide, H2O2, like that. Then you have KMNO4. So this is one of the most efficient way of treating this water for disinfection. So for disinfection, there are basically two methods, physical method and chemical method. In physical method, we have boiling and UV ray treatment. In chemical method, we have treatment by acids and alkalis, treatment by metallic ions, and treatment by oxidizing agents. Oxidizing agents include chlorine, ozone, then peroxide, then KMNO4. So all these are the methods of disinfection. Now practically we actually treat water using the chemical method of disinfection, and especially treatment by oxidizing agent. This is the sole method of treating water on the mass scale. Means if you need to supply water to the community, then instantaneous treatment is required. And for instantaneous treatment, we go with treatment by oxidizing agent, and in India, we go with treatment with chlorine. Okay. Ozone, this UV ray treatment is also a very efficient method of treating the water for disinfection, for killing the microorganism. But again, treatment with this UV ray is a very costly affair. That's why we don't go with this method. Chalo, one by one we will see. Topic number 1 is minor methods of disinfection. Minor methods of disinfection. So the first minor method of disinfection is treatment with ozone. The first minor method of disinfection is treatment with ozone. Treatment with ozone. That is O3 negative. Now my dear students, when you have read this ozone back in the chemical bonding, if you can just collect few things, that this ozone contains one nascent oxygen, and that nascent oxygen is highly reactive in nature. Means if anything comes in contact with the nascent oxygen present in the ozone, it will quickly going to oxidize it. And that mechanism we use for disinfecting the water through ozone. So the first point in ozone is ozone contains nascent oxygen, which is a very strong oxidizing agent. Ozone contains nascent oxygen. Ozone contains nascent oxygen, which is a very strong oxidizing agent. Which is a strong oxidizing agent. Which is a strong oxidizing agent. Now what happens is, when you add this ozone in the water, the microorganisms that are present in the water have a cell wall like this. These are the microorganisms which are present in the water. So these are the microorganisms which are present in the water, right? I am just drawing a microorganism. So this microorganism will contain this cell wall. This is the cell wall of the microorganism, right? Some biology is coming into play. I think you are just recalling your days of biology when you have read this in your 10th class. But I think this much you remember, that all the microorganism contains cell wall. Just like our skin we have, microorganism have the cell wall, and inside some fluid is present which is required for the life of the microorganism. So essential fluid is present in between, and it is covered by the cell wall of the microorganism. This nascent oxygen present in ozone destroys this cell wall. This nascent oxygen which is present in ozone destroys this cell wall, and due to this destruction, all the essential fluid which is responsible for the life of the microorganism, it flows out and leads to the killing of microorganism. Again, I'll repeat myself. Microorganism has a cell wall inside which essential fluids are present. This nascent oxygen destroys this cell wall, due to which all the essential fluid flows out and it leads to the killing of microorganisms. So ozone, so this is the cell wall of the microorganism, and inside it you have these essential fluid like this. These are the essential fluid that are present inside the cell wall, and these fluids will going to flow out. So I'll just summarize this. Ozone destroys the cell wall. Ozone destroys the cell wall. Cell wall of the microorganisms. Due to which essential fluid flows out. Flows out, which leads to the killing of microorganisms. Which leads to the killing of microorganisms. I think this is a very easy, simple step to remember, right? What does ozone will do? Ozone has a nascent oxygen which is highly reactive in nature. And this nascent oxygen is also a very strong oxidizing agent. When this nascent oxygen comes in contact with the cell wall of the microorganism, it destroys the cell wall, due to which all the essential fluid moves out and it leads to the killing of microorganism. Now, my dear student, this ozone you have added in the treatment plant. So all the ozone have been utilized in the treatment plant itself. When this water is supplied in the community by the use of distribution system, due to different leakages, there is a possibility that recontamination can happen while supplying this water to the community. Now, if you are treating water using ozone, then this ozone cannot take care of that future recontamination that may happen while supplying this water into the community. So in this scenario, ozone does not act as a very good disinfectant, although in the treatment plant is a very effective disinfectant. But because of this high reactive nature, it cannot take care of the future recontamination, which is one of the most important part of treatment. We need to use a disinfectant in such a way that it takes care of the present disinfection, and also it should be responsible for treating the water if any future recontamination can happen while distributing this water into the community. So that's why ozone is not preferred for Indian conditions, and also it is a very costly disinfectant. So I will write here, ozone being highly reactive in nature, ozone being highly reactive in nature, cannot take care of future recontamination. Of future recontamination while supplying the water in the community. The next point is, ozone is a very costly disinfectant, hence not used for Indian conditions. Ozone is a very costly disinfectant, hence not used to treat community water. You can write like this. Ozone is a very costly disinfectant, hence not used to treat, hence not used to treat community water. That is water supplied to the community. For that, we don't go with the treatment with ozone, right? So what does ozone do? So we have read the first minor treatment, and that is treatment using ozone. Just 1 second. Okay, so this is the first minor method of treatment, right? Second minor method of treatment is treatment with KMNO4. Second minor method of treatment is treatment with KMNO4. Now, my dear students, this chemical is basically used to treat well water. That is, if you see disinfection carried out in villages, wells present in villages, usually we go with the treatment with KMNO4, right? It's a pink color substance. If you add this KMNO4 to water, it's a pink color substance, right? So it is basically used to treat well water. It is used for the treatment of well water. So what we do basically, we add KMNO4 in the well, and we don't utilize this water for next 48 hours. We leave this water for 48 hours, and in 48 hours, this KMNO4 will carry out the disinfection of all the pathogens which are present in the water. So KMNO4 is added in the well water. KMNO4 is added in the well water. Is added in the well water, and it is left for 48 hours. Okay. Now what happens here? Again, you take this microorganism. This is the microorganism that we have, right? And this microorganism contains cell wall. This I have already told you. This is the cell wall of microorganism. This is the cell wall of microorganism. Okay. Now, just like our skin, right? The cell wall of the microorganism also contains some pores. These are the pores which are present on the cell wall of the microorganisms. These are the pores which are present on the cell wall of the microorganism, like this. These are the pores which are present on the cell wall of the microorganism. Now, what does this KMNO4 will do? KMNO4 will increase the permeability of these pores which are present on the cell wall of the microorganism. Due to the increased permeability of these pores, whatever essential fluid is present inside the cell wall, that essential fluid will flow out, and again it will lead to the killing of the microorganism. So KMNO4 basically increases the permeability of the pores present in the cell wall, due to which all the essential fluid which is present inside the microorganism will flow out, and it will lead to the killing of microorganism. All the essential fluid will flow out through these pores, and it will lead to the killing of the microorganism, like this. So this is how all the essential fluid will flow out, leading to the killing of the microorganism, like this. So KMNO4 basically increases the permeability of the pores present on the cell wall of the microorganisms, due to which all the essential fluid flows out and leads to the killing of microorganisms. So I'll just write like this. So KMNO4 increases the permeability of the pores present on the cell wall due to which all the essential fluid flows out, due to which all the essential fluid flows out, leading to the killing of microorganism. Leading to the killing of microorganisms. Okay. Now again, this KMNO4 is not used to treat the community water. Reason being, the chemical reaction that takes place through this KMNO4 is a slow reaction. It requires like 48 hours for all the microorganisms to get killed. That's why this KMNO4 is never used to treat the community water. It is only used to treat well waters. That's why most of the disinfection that is carried out in villages is carried out using the KMNO4, right? So this KMNO4 is also not used to treat community water. KMNO4 is not used to treat community water. To treat community water. Okay. So I am just discussing the basics. I am not getting into much detail. Reason is sir KMNO4 कहाँ से आया? जहाँ से ओजोन आया, जहाँ से क्लोरीन आया, वहीं से KMNO4 भी आया. तो KMNO4 is not used to treat community water, right? Okay. So these are just the basics regarding ozone and KMNO4. Ozone basically destroys the cell wall, leading to the killing of microorganisms, whereas KMNO4 actually increases the permeability of the pores present in the cell wall, again leading to the killing of microorganisms. Okay, so these are the two minor methods of treatment which is not used to treat the community water. Now coming to the major method of treatment that we actually perform in our water treatment plant. So major method of treatment that we use for disinfection is treatment with chlorine. So major method of treatment that we use in our treatment plant to carry out the disinfection is treatment with chlorine. Usually in all parts of India, we go with this treatment. So treatment with chlorine is the mostly used disinfection unit in all the treatment plant. Treatment with chlorine. Now you see this. This is one of the most important mechanism that we read in the treatment of raw water. So treatment with chlorine is the most extensively used disinfection procedure in all the water treatments, especially the raw water treatments. Now see what happens. Chlorine is added in water. Chlorine is added in water. I am writing point by point because every point is important, right? Chlorine is added in water. Chlorine is added in water. Chlorine is added in water. Now chlorine is available in all the three forms. Either you can add them as a gas, you can add them as a liquid, you can add them as a solid. The chlorine which is added in water is known as the free form of chlorine. Okay. So chlorine is added in water. It can be added either as a gas or as a liquid or as a solid. In all the three forms, the chlorine is available, right? You can add this chlorine in any form. Chlorine is added in water. Now this chlorine reacts with the water. This chlorine reacts with the water to form hypochlorous acid. This chlorine reacts with the water to form hypochlorous acid. When the pH is greater than 5, it has to be maintained. When the pH is more than 5, this equilibrium will go in the forward direction. This is free chlorine. This is hypochlorous acid. All the names are important. This is free chlorine. This is hypochlorous acid. Now this hypochlorous acid HOCl, it further dissociates into hypochlorite ion. This HOCl dissociates into hypochlorite ion. This HOCl dissociates into hypochlorite ion, OCl minus and H plus. This reaction goes forward if the pH of the water sample is greater than 8. And this reaction will go backwards if the pH of the water is less than, right? So this is how the reaction takes place. You add chlorine, chlorine will react with water to form hypochlorous acid. This hypochlorous acid further dissociates into hypochlorite ion and H plus ion. So this is my hypochlorite ion. This is the hypochlorite ion, right? Now you see this. When you have added chlorine, chlorine is now available in three forms. These are the three available forms of chlorine. This is first form of chlorine. This is the second form of chlorine. And this is the third form of chlorine. All these three forms of chlorine are capable of carrying out the disinfection. And these three forms of chlorine are known as free forms of chlorine or freely available chlorine. Cl2, HOCl and OCl minus. Cl2, Cl2, HOCl and OCl minus. Cl2, HOCl and OCl minus are known as free forms of chlorine. These are known as free forms of chlorine. These are known as free forms of chlorine. All these three forms of chlorine are capable of carrying out the disinfection. All the three forms of chlorine, all the above forms of chlorine, all the above forms of chlorine, all the above forms of chlorine are capable of carrying out the disinfection. Are capable of carrying out the disinfection. Are capable of carrying out the disinfection, right? All these three forms of chlorine are capable of carrying out the disinfection. Now you observe one point. Cl2, HOCl and OCl minus. These are the three free forms of chlorine. Out of these three free forms of chlorine, HOCl is the most destructive form of chlorine that carries out most of the disinfection. Out of all the three forms of chlorine, HOCl is the most destructive disinfectant. HOCl is the most destructive disinfectant. Out of all the three available forms of chlorine, out of all the three freely available chlorine, freely available forms of chlorine, HOCl, please remember this, HOCl is the most destructive disinfectant. Is the most destructive disinfectant. HOCl is the most destructive disinfectant, right? So if we are adding chlorine, we want that all the treatment or all the disinfection should be carried out by this HOCl. So simultaneously we maintain the pH in such a way that HOCl predominates in the system. So if you look into the different forms of chlorine, if you talk about free chlorine is available when the pH of the water is less than 5. When pH of the water is less than 5, then you have this free chlorine. If I talk about HOCl predominates in the system when pH of the water sample is between 5 to 7. When pH of the water sample is between 5 to 7, then your HOCl predominates in the system. You will get the combination of HOCl and OCl minus ions if the pH of the water sample is between 7 to 8. If the pH of the water sample is between 7 to 8, then simultaneously hypochlorous acid and hypochlorite ion both will be present in the system. But if pH of the water sample is more than 8, then hypochlorite ion will be predominating in the system. If pH of the water sample is more than 8, then hypochlorite ion will be predominating in the system. Okay. Now, out of all these three freely available forms of chlorine, HOCl is the most destructive disinfectant. Being the most destructive disinfectant, it should be responsible for carrying out maximum disinfection that is taken by the community water. So while carrying out the disinfection, we maintain the pH in this range so that HOCl predominates in the system and we have the maximum efficiency of disinfection. So while carrying out the disinfection, the pH of the water sample is maintained in the range of 5 to 7. You can just have a note point regarding this because this can be a statement for a multiple select question. While carrying out the disinfection, while carrying out the disinfection, while carrying out the disinfection, pH of the water is maintained in the range of pH of the water is maintained in the range of 5 to 7. Because when the pH is maintained in the range of 5 to 7, then HOCl will be predominating in the system, and HOCl will be the most destructive disinfectant which carry out the disinfection, and we will have the most or the highest efficiency of disinfection. So pH of the water sample while disinfecting the water is maintained in the range of 5 to 7. Please note this point down, right? While carrying out the disinfection, pH of the water is maintained in the range of 5 to 7. This is the first note point. The second note point is, all these free forms of chlorine, what they do is, they kill the enzymes which are responsible for the metabolism of microorganism. There is a metabolism that is means present in all the living beings, and because of this metabolism you are alive. If your metabolism stops, you will be dead the next moment, right? In the same way, there is a metabolism for microorganisms for which certain enzymes are responsible. So all these three free forms of chlorine, they destroy those enzymes which are responsible for the metabolism of microorganisms, and hence leads to the killing of microorganisms. So free forms of chlorine, or I will write like this, chlorine destroys the essential enzymes which are responsible for the metabolism of microorganisms, which are responsible for the metabolism of microorganisms, hence leads to the killing of microorganisms. Hence leads to the killing of microorganisms, right? So basically, this chlorine is responsible for destroying the enzymes, and these enzymes are responsible for carrying out the metabolism of the microorganism, hence leads to the killing of these microorganisms, right? So this is one part of adding the chlorine. When you add chlorine, chlorine will also react with the ammonia present in the organic matter, and this organic matter is present in the water, right? Water contains organic matter and organic matter contains ammonia. When you add chlorine to this water, some part of this chlorine will also react with this ammonia present in the organic matter and leads to the formation of chloramines. So first reaction that chlorine will do is chlorine will dissociate into hypochlorous acid and hypochlorite ion. The next thing that this chlorine will do is it will going to react with the ammonia present in the organic matter, and it leads to the formation of chloramines. So chlorine reacts with, I'll write here, chlorine also reacts with Chlorine also reacts with the ammonia present in the organic matter to form chloramines. Right? To form chloramines. These chloramines are also known as combined form of chlorines. These chloramines are also known as are also known as combined form of chlorine. Combined form of chlorine. These chloramines are also known as combined form of chlorine, right? Now see this, combined form of chlorine. All these terms are very important because in the questions we are unable to identify which type of chlorine is given to us, whether it is a freely available chlorine or whether it is a combined form of chlorine. Now you see this. Chlorine reacts with the ammonia present in the organic matter to form chloramine. So chlorine reacts with the ammonia to form monochloramine, NH2Cl. NH2Cl is monochloramine. Then this NH2Cl again combines with another chlorine. This NH2Cl combines with another chlorine to form dichloramine, NaCl2. Monochloramine, then you have dichloramine. Then this dichloramine again combines with a chlorine to form trichloramine or nitrogen trichloride. This dichloramine again combines with one more Cl2 to form nitrogen trichloride or trichloramine. This is known as nitrogen trichloride or trichloramine. This NH2Cl, this NHCl2 and this NCl3, all these are known as combined form of chlorine and these are known as chloramines. So I will write here NH2Cl monochloramine, dichloramine NHCl2 and NCl3 nitrogen trichloride. All these are known as combined form of chlorine. These are known as combined form of chlorine. Combined form of chlorine. And these are also known as chloramines. These chloramines also carry out the disinfection, but these chloramines are less destructive disinfectant as compared to the freely available forms of chlorine. So these chloramines are also capable of carrying out the disinfection. They are also capable to carry out the disinfection. To carry out the disinfection. But they are less destructive than freely available forms of chlorine. But they are less destructive than freely available forms of chlorine. But they are less destructive than freely available forms of chlorine, right? So when you add chlorine into the water, it will be present in two forms. First is the freely available form of chlorine, and second one is the combined form of chlorine. Freely available forms of chlorine are more destructive than combined form of chlorine, and in the freely available form of chlorine, HOCl is the most destructive disinfectant to carry out the disinfection of water. These combined forms of chlorine, they are a bit stable kind of a compound. They are not that much reactive as compared to the freely available forms of chlorine. So these combined form of chlorine stays in the system for longer duration. Due to this reason, these combined form of chlorine take care of the future recontamination. So if I have to summarize this entire story, I would write like this. When chlorine is added in water, when chlorine is added in water, chlorine is added in water, when chlorine is added in water, it forms freely available forms of chlorine, freely available forms of chlorine, freely available forms of chlorine. That includes Cl2, HOCl and OCl minus. So these are the freely available forms of chlorine. At the same time, it will also lead to the formation of combined form of chlorine. Combined form of chlorine. Combined form of chlorine, which are known as chloramines. Now, out of these chloramines, you have monochloramine, NH2Cl, dichloramine, NHCl2, and then you have nitrogen trichloride, NCl3. So you can see here, you have seen there are 6 different forms of chlorine which are carrying out the disinfection. Out of this 6 form, HOCl is the most destructive disinfectant. HOCl will carry out most of the disinfection. That is why we maintain the pH with respect to HOCl. So that's why the pH of the water sample is maintained in the range of 5 to 7 while carrying out the disinfection. Okay. Combined form of chlorine, they are less reactive as compared to the freely available forms of chlorine. That's why these combined forms of chlorine stays in the system for longer time. Therefore, this combined form of chlorine takes care of the future recontamination. So, combined form of chlorine, combined form of chlorine, combined form of chlorine are less reactive than freely available forms of chlorine. Freely available forms of chlorine. Hence, these combined forms of chlorine, combined forms of chlorine takes care of future recontamination. Combined forms of chlorine takes care of future recontamination. Future recontamination. Takes care of future recontamination, right? So if any question comes, which form of chlorine takes care of future recontamination, it has to be combined form of chlorine. And the reason is simple. Combined form of chlorine are less reactive as compared to the freely available forms of chlorine. Due to this reason, combined form of chlorine stays in the system for longer duration and takes care of future recontamination. Okay, so these are some of the basics that we start analyzing the disinfection process. Now, the another basic for analyzing the disinfection process is kinetics of disinfection. Kinetics of disinfection. So what does kinetics of disinfection mean? Kinetics of disinfection means simply that if initially n naught amount of microorganisms are present, sir, but Cl2 direct, one second, Cl2 direct not react with NH3. NH2Cl plus OCl minus gives NH2Cl plus H2O. Beta, hypochlorous acid and hypochlorite ion does not react with ammonia. Free forms of chlorine react with ammonia. Free chlorine reacts with ammonia. That is Cl2 reacts with ammonia. That is why we are getting these chloramines. Okay. Now we are talking about kinetics of disinfection. Kinetics of disinfection means simply if initially n naught amount of microorganisms are present in the system, then after T time, how many microorganisms are present in the system or how many microorganisms got killed after time T. That is what we mean by kinetics of disinfection, right? So first of all, kinetics of disinfection follows the first order kinetics, or the killing of disinfection or the rate of change of microorganisms follows first order kinetics. Rate of change of microorganisms, rate of change of or the rate of disinfection, you write like this, rate of disinfection, rate of disinfection follows first order kinetics, follows first order kinetics. Rate of disinfection follows first order kinetics, that is killing of microorganisms follows first order kinetics. You see like this. If on the x-axis I will plot the time and on the y-axis I plot the number of microorganisms that are present in the system. X-axis is the time axis and y-axis is the number of microorganisms present in the system. Number of microorganisms present in the system. So initially, if n naught amount of microorganisms are present in the system, the number of microorganisms will keep on decreasing as more and more disinfection is carrying out in the system, right? Initially, if n naught amount of microorganisms are present, it keeps on decreasing as more and more amount of disinfection is carried out. So at any time t, if the number of microorganisms present in the system are nt, at any time t, if the number of microorganisms present in the system are nt, then the rate of change of microorganisms, that is minus dnt by dt. This is the rate of change of microorganisms, dnt by dt. The rate of change of microorganism minus I have kept because the number of microorganisms are reducing. So minus dNt by dt is directly proportional to the number of microorganisms present in the system. Means the rate of change of microorganism in the system is directly proportional to the number of microorganisms present in the system. You can also see with this graph. The slope of this graph is continuously reducing. And the reason is the number of microorganisms present in the system is also reducing. So the slope of this graph is nothing but the amount of microorganisms which are present in the system. So the rate of change of microorganisms in the system is directly proportional to the amount of microorganisms present in the system. Removing this proportionality sign, you have minus dNt by dt is equal to K into Nt. Now this K is known as the disinfection constant. This K is known as the disinfection constant. This is known as the disinfection constant. This K is known as the disinfection constant. Okay, just rearrange the terms. So you have minus dNt by Nt is equal to K into dt. Okay, you can take the minus sign to the other side. So you have dNt by Nt. You have dNt by Nt is equal to minus K into dt. Just integrate this expression. On integrating this expression, so at time t is equals to 0, the number of microorganisms present in the system were n naught. At time t is equals to t, the number of microorganisms present in the system is nt. So you have to just integrate this. This will be natural log of nt by n naught equal to minus k into t. Okay, so this is how the integration will look like. Just take the nt log. So you have nt by n naught is equal to e raised to the power minus kt. So from here I can have an expression which is nt is equal to n naught into e raised to the power minus k into t. Nt is the number of microorganisms present in the system after any time t. N naught is the total number of microorganisms present in the system initially. T is the time after which you want to calculate the number of microorganisms present in the system. This law is known as the Chick's law of disinfection. This is known as the Chick's law of disinfection. This is known as the Chick's law of disinfection. This is known as the Chick's law of disinfection. Again, one of the very important law. This year also in GATE 25, we have seen a relative question from the Chick's law. If a question is framed from disinfection, there are good chances that you may get a question from this Chick's law. I will write down all the details. So NT is, or I would like this, N naught is the total amount of microorganisms, is the total number of microorganisms, is the total number of microorganisms present in the system or present in the water sample initially. Present in the water initially. NT is the number of microorganisms present in the water after time t. Is the number of microorganisms present in the water after time t. After time t, right? It is again a very, very important law, Chick's law, which tells us the relation between the number of microorganisms present in the system to the number of microorganisms initially present. And K is nothing but the disinfection constant, and T is the time after which you are analyzing, okay? Or the time after which you want to calculate the number of microorganisms. These are some of the basics that will be required to deal with the question of disinfection. After this, we have a great analysis which is known as the breakpoint analysis. Then we have different types of chlorination. In that only we read about the breakpoint analysis for chlorination, right? So this is what I have to offer for the foundation course of disinfection, or especially this session of disinfection. I hope you have read enough. You have understood properly what is the difference between disinfection and sterilization. Disinfection is the killing of pathogens, whereas sterilization is the killing of all types of microorganisms. Disinfection is carried out either physically or chemically. Physical disinfection includes boiling or UV ray treatment, and chemical disinfection includes treatment with acids and alkalis, treatment with metallic ions, and treatment with oxidizing agents. We have seen the minor methods of treatment. First one is treatment with ozone. So ozone, being highly reactive in nature, destroys the cell wall of the microorganism, leading to the killing of microorganism. Because of high reactivity of ozone, it cannot take care of future recontamination. Second, treatment with KMNO4. So KMNO4 basically increases the permeability of the pores present on the cell wall, due to which all the essential fluid flows out and leads to the killing of microorganism. Again, KMNO4 is not used to treat the community water because it requires a lot of time for carrying out the disinfection. Third one is treatment with chlorine, which is the major method of treatment. When you add chlorine to water, it is available in two different forms: free forms of chlorine and combined forms of chlorine. Free forms of chlorine are more destructive than combined form of chlorine, and in free forms of chlorine, HOCl is the most destructive form of chlorine which can carry out the disinfection. That's why the pH of the water sample is maintained in the range of 5 to 7, so that HOCl predominates in the system and it gives the maximum efficiency of disinfection. Combined form of chlorine actually takes care of the future recontamination. Then we have seen the kinetics of disinfection, and we have defined the Chick's law, which tells us about the number of microorganisms present after time t is equal to the number of microorganisms initially present into e raised to the power minus k into t. After that, we read about the different types of chlorination. There we read about the breakpoint chlorination, and that is how the entire topic closes regarding the disinfection. If you want to read everything, join our offline program or online program that we provide at IMS Gate Academy. So before closing this, again I would like to make few announcements. The first announcement is regarding our Telegram group, my dear students. The link is given in the description box. If you want to have this lecture PDF, it will be available in the Telegram group. If you want to have the YouTube schedule, again it will be available in the Telegram group. We regularly post the questions as in a form of quiz, so you can enjoy the daily quizzes. If you want to have any job notification update, we create the video and the link we provide in the description box, in the Telegram group, and we regularly conduct webinars for your awareness regarding the different exams and regarding the preparation strategy of GATE and the other examination. So again, you can join our Telegram group for the same. We at IMS Gate Academy, we provide you with 4 different types of courses where we provide 800 hours of live teaching with doubt solving, with interaction. Along with that, we provide you with theory and exercise book. In our exercise book, there are more than 4,000 plus practice questions, well versed in level 1, level 2 and level 3. Along with that, we provide you a comprehensive GATE question bank containing 34 years of GATE questions, in which we have provided the detailed solution, alternate solution, video solution, key points and chapter overview. Along with that, we provide 12 personalized one-to-one mentoring sessions so that your preparation stays oriented and monitored over the entire GATE preparation journey. Lastly, we provide you with India's largest test series containing 130 plus tests, starting from the chapter test, subject test, multiple subject test, advanced subject test, along with the full-length mock test. So this is what I have to offer for today. Join me again tomorrow, same time, same place at 4 p.m. on IMS Gate Academy YouTube platform. Myself, Prateek Mishra, signing off with a smile and wish you all the best. Thank you so much.